Okay, this is Florent, the mathematics user, and we are looking at rates of change, and it falls under application of differentiation. So on the board, the question says a spherical balloon is being inflated, and the volume is increasing at the rate of 15 centimeters cube per second. At what rate is the radius increasing when it is 10 centimeters? Okay, so let's analyze the question. First, we have here a spherical balloon. Two, we have volume. And the third one, the key thing here, we have radius. So first of all, let's focus on the volume of the spherical balloon. Now, volume of a sphere is basically 4 on 3 pi r cubed. Now, the volume is increasing with respect to the radius. So therefore, we are going to find dv dr because volume increases with respect to radius. And this is going to give us 3 multiplying 4 on 3 pi r, then here becomes 3 minus 1. Giving us, this will cancel out, where we have 4 pi r squared. Now, it says that the volume is increasing at the rate of 15 centimeters cube per second. Here, we are dealing with volume and time, which means that the volume varies with respect to time. So now we also need to find our volume, which varies with respect to time, which was giving us 15. Okay, let's move on. The next part, it says at what rate is the radius increasing when it is 10 centimeters? At what rate? Rate deals with time. So which means that we need to know rate, the rate at which the radius is increasing with respect to time, which is dt. So we need to find the r dt. And here we are going to apply the chain rule. Now the r dt is going to give us the r dv multiplying dv dt. Why? Look here. Here we are supposed to solve this. dv will cancel out dv. Now we'll get the r dt. Now let's come back to what we've done here. Now over here, we know, we could easily know dv dt as 15. So here is going to be 15. But here we have the r dv. But over here we have dv dr. What's the relationship? One is the inverse of the other. So it means that our dr dv will be 1 on 4 pi r squared. Now let's move on. When we multiply this, we are going to obtain 15 on 4 pi r squared. So our dr dt is 15 on 4 pi r squared. But now we're told that we should find the rate. At what rate is the radius increasing when it is 10 centimeters? So now the radius is given. So when we continue, we have 15 here over 4 multiplying pi, then our radius, which is 10 here, to the power 2. Let's use a calculator. Okay, let's see. So here we are going to have 15 over 400 pi. 15 over 400 pi. Okay, so 15 over 400 pi. Let's use the calculator. So we have 15 dividing 400 pi, and pi is 22 over 7. So this is giving us 0.011 93. Now we can make it so we can leave it to, let's say, 3 decimal places, which will give us 0.012 centimeters per second. So the rate at which the radius increases when it is 10 centimeters is 0.012 centimeters per second. And this is Florence, the mathematics user.